This time, we are already assured that the given star operation is a binary operation. Of course, if you would like to check that, there will be a separate video for that. But here, the main goal of this video is to determine whether the given set, the set of real numbers, except for -1, is a group under the operation star defined as A star B is equal to A plus B plus AB. Of course, our description here, we have usual addition and usual multiplication. Most of the time, we will have it as binary or closed. I mean, the point here is the closure property. But we have the exemption of 1. Again, we will not be talking about that. There might be a separate video discussing as to how this became a binary operation. Our goal here is to satisfy 3 conditions for the said set to be a group under the given star. The first condition is G1, the identification whether star is associative in R. Again, except for the set containing -1, because we will not be including -1 as defined and in our given. So we are going to see whether this is associative. But of course, the general rule for associativity is that if you're going to pick 3 elements and group the first 2 before implementing the set operation or same operation to the third, this is equal to having A, the first, star B star C, by letting A, B, and C element of our real numbers minus or except set containing -1. Okay, so we will have it like that for the purpose of exclusion of -1 as indicated. But of course, again, the general rule is we need to make sure that this is associative first. So let's try to come up with the left hand side, A star B star C. So we're going to implement this first. This would become equal to A plus B plus AB as indicated here in the definition. But this entire trinomial expression will still be subjected to our C. Okay? So what does this tell us? We're going to treat this as 1 actually. Okay, that would be our new A and our C would be our B's here. This would mean this would be our A plus B plus AB. That's our A plus our B, which is C, and plus the product of the two, A plus B plus AB times C. Let's find out what will be the result of this. Of course, you have A plus B plus AB plus C here, plus AC as you distribute that, plus BC plus A, B, and C. So the result here, okay, the result here is equal to A plus B. Let's just simply rearrange it, plus C. So we have 1, 2, 3, plus AB plus BC plus AC plus ABC. This is for the left-hand side of the associativity. Now let's proceed to the right-hand side here. So we have A star, applying the star operation for B and C. So we'll have B plus C plus BC. Now treating this as a new expression or a singular expression, you have here A plus that entire expression, B plus C plus BC plus AB here, which means the product of A and the second expression. So this would mean you have A plus B plus C plus BC, and as you distribute that, you have plus AB plus AC plus AB and C. Arranging them, you have A plus B plus C. Let's start with AB, so it will be the same as the other, plus BC plus AC plus AB and C. We could see that the result for the left hand side is just the same as the result for the right hand side. This means that star is associative in the set of real numbers except for the set containing -1 as indicated in the definition. Now G1 has been satisfied. With this, let's proceed to our G2. Let me use color black here. Okay. G2 is all about the existence of identity element. Take note that the operation A star B is defined as A plus B plus AB. Let's take note of that. So we're going to let here a certain A element of our real numbers except for set containing -1. And we're going to find E, still element of the set of real numbers except for the set containing -1, such that we have A star E is equal to E star A equal to A. For we're going to for equal to A. Okay, that would be for all A element of set real numbers less -1. So we could establish this, and we could find a certain element E, which would be true for all. Then we can say that the identity element is present and G2 is satisfied. So how do we show it like this? Since our set is infinitely many, let's just try to come up with the algebraic expression that would stand for both. Okay, so you have here A star E. Using the definition here, you have A plus E plus AE. Okay, that's it. Then that's for our first expression. For E star A, you will have here E plus A plus EA. But then again, this is usual addition, usual multiplication. You can simply rearrange it because usual addition and usual multiplication is commutative, plus E plus AE. So we can establish that they have the same results now. And what would be our expression next? Because we need to show a certain E. We can choose any of this. A plus E plus AE is equal to, here, A. Let's find out what would be the representation. General representation, algebraic expression, algebraic representation for our E. So since we have A here on both sides, we can subtract A. You have E plus AE is equal to 0 on the other side. So E factoring E, 1 plus A is equal to 0. When dividing both sides by 1 plus A, 1 plus A, our E is actually just equal to 0. Of course, you can automatically say, the identity for that, because it's on usual addition, we have here 0. And 0 is still element of set of real numbers except for -1. This would mean that G2 is satisfied. We have determined the existence of an identity element, and that's specifically 0 for this given group. Not yet group, for this given set under the operation star. Okay, I'm not saying it's a group because we still have our third condition, G3. So again, let me rewrite it here. A star B is equal to A plus B plus AB. So what is this third condition? The third condition focuses on the existence of an inverse element for all element in the given set. So let A element of did I use R? Yeah, R less -1. So we're going to find the inverse of A. Still element of this, okay? It should be element of the same set, such that A star the inverse is equal to the inverse star A equal to E, which is 0. Okay? So we're going to look for that. So for the first expression, again, since our set is infinitely many, we're just going to have algebraic representations. Okay? So this would follow A plus A inverse plus A times A inverse. For the second, A inverse star A, you have A inverse plus A inverse A. Again, usual addition, usual multiplication, it's commutative. So A plus A inverse plus A times A inverse. Now they are now the same. These two expressions, or this expression, because they are just the same, must be equal to E, which is 0. So you have A inverse, plus A inverse plus A times A inverse must be equal to E, which is 0. And let's find out the inverse of A. And this should be for all. Okay? So let's have here A. We call this one. This would be, let me remove E first, plus A inverse is equal to 0. Now we were solving for A inverse, so let's subtract both sides by A. You will have here A inverse plus A times A inverse is equal to negative A. Then we factor A inverse, you have 1 plus A is equal to negative A. So our A inverse must be equal to negative A over 1 plus A. This is the general representation of our inverse for all elements of A. Okay? For all elements. Of course, there will be a specific inverse for each, but this is the representation for all. Now, is this an element of the given set? Take note that this is a rational expression. And what the only restriction for rational expression is that the denominator, okay, 1 plus A should not be equal to 0. If it's equal to 0, okay, we will have here a result that A is negative 1, right? This will only be imaginary, or the inverse is not possible, or the inverse is not existing if our A is negative 1. However, take note, our set is already defined as a set of real numbers except negative 1. What does this tell us? We are now already excluding negative 1 on the set. This would mean this will never be possible and this will never be undefined. This means this representation for our inverse is true, and in this case, this is still element of our set of real numbers except the set containing negative 1. Hence, G3 is satisfied. Okay? So with this, G3 is satisfied, G2 is earlier satisfied, and of course, though very long, our associativity G1 is also satisfied. Then we can say now, I have a space here, let me go back to my white color. We can say that the set R, except for the set containing negative 1, is a group under the given star operation. Let me highlight that. We have now established that this is a group, or this set is a group under the given star defined as A star B equals A plus B plus AB. Thank you very much for watching.